Hello, everyone. In this lesson, we're going to be reviewing fractions and equivalence, which is another foundational topic on this exam. We need to understand what fractions represent, how to compare them, and why fractions have the same value, even when they're written with different digits. Let's go ahead and get started. A fraction represents a relationship between two numbers. So let's look at the fraction 3/4. The number in the top is what we call the numerator, and the number in the bottom is what we call the denominator. The denominator tells us that our whole has been divided into, in this case, 4 equal parts. Our numerator, which is the top number, tells us that we're talking about 3 of those equal parts. One common misconception is that fractions only represent part of a whole. And while that's certainly one way to interpret them, fractions can also represent division, ratios, or even act as an operator. For example, if you need to find 1/2 of a quantity. So on the CSET exam, it's really important to understand these different meanings of fractions. Let's go ahead and take a second to talk about equivalent fractions. Equivalent fractions are different fractions that represent the same value. So for example, let's draw 1/2. Remember, the bottom number tells me how many parts I need in my whole. In this case, I need my whole in 2 parts. The top number tells me how many pieces of this whole I am talking about, I'm representing. So it would be one of these pieces. This is 1/2. One thing we can do to get equivalent fractions is multiplying the numerator and the denominator by the same value. Let's do that with the number 2. We'll multiply the numerator and the denominator by 2. When we do this, 1 times 2 is 2. 2 times 2 is 4. 1/2 and 2/4 are equivalent fractions. If I draw 2/4, you'll see that. So I have my 1 whole. I'll divide it into 4 pieces because there's a 4 in the denominator. And I'll fill in 2 of those pieces because there is a 2 in the numerator. If you look at my 2 drawings, you see that I've filled in the same amount of the whole. Let's do one more example. Let's start with my 1/2. And this time I'll multiply the numerator and the denominator by 3. 1 times 3 is 3. 2 times 3 is 6. Let's go ahead and draw this one. I divided my whole into 6 pieces because there's a 6 in the denominator, and I'm going to fill in 3 of those pieces because there's a 3 in the numerator. If we look at my 3 circles here, I filled in the exact same amount for all 3. So even though the numbers have changed, right? We're looking at 1/2, 2/4, and 3/6. The value of the fractions have not. And why is that the case? Well, we're actually multiplying by a form of 1 every single time. For example, here, 2 divided by 2 is equal to 1. And 3 divided by 3 is also equal to 1. Multiplying by 1 does not change the value of a number. And that's why we can multiply both the numerator and the denominator by the same number and create equivalent fractions. Please note that you cannot do this with 0. 0 divided by 0 is undefined. We can also simplify fractions by working in reverse. So let's start with an example, 12/18. First of all, we're going to find the greatest common factor of 12 and 18. What is greatest common factor, GCF? The greatest common factor is the largest number that divides evenly into 2 or more numbers. For example, for 12 and 18, this would be the number 6. How do we find that? Well, what you should do is maybe start by listing all of the numbers that multiply to make each of our target numbers. What we're going to do is write those 2 lists and find the largest number that's on both of the lists. Let's go ahead and write all of the factors of 12 and 18. So for 12, I can do 1 times 12. I can do 2 times 6. And I can do 3 times 4. You can actually write those in whatever order you want as long as you don't miss any. I like to write them from least to greatest so I can easily identify what the greatest values are at the end. Let's also write the factors of 18. There's 1 times 18, 2 times 9, 3 times 6. Looking at my two lists here, I see a number of values that are shared between the two lists, including 1, 2, 3, and 6. These are what we call the common factors. However, for GCF, the greatest common factor, we're only interested in the largest number shared between those two lists, which is 6. Let's come back to why we even needed the greatest common factor. We need the greatest common factor in order to simplify our fraction. So what we're going to do is we're going to divide the numerator and the denominator by our GCF, our greatest common factor. 12 divided by 6 is 2. 18 divided by 6 is 3. This is our simplified fraction. Please remember that simplifying fractions, just like writing equivalent fractions, doesn't change any of the values. We're simply writing the same fraction in different ways. Another important skill is comparing fractions. If the denominators are the same, then we can simply compare the numerators. For example, 5/8 is greater than 3/8. This is because 5/8 represents more parts of the whole than 3/8 does. If we draw it, we'll see that. As you can see, we filled in more pieces for 5/8 than we have for 3/8. What do you do, though, when the denominators are not the same? For example, when comparing 1/3 with 1/4. There are a couple of ways to approach this. You can either try to find a common denominator or use some benchmark fractions. For example, thinking about how each of these compares with 1/2 or 1/2. When looking at these two fractions here, you might already immediately be able to tell which one is greater. And that's because you know that 1/3 is one piece out of a whole cut into 3 pieces, whereas 1/4 is what you get when you cut your whole into 4 pieces. The pieces of this whole cut into 3 are larger than the pieces of the whole cut into 4. So just by visualizing a bit, we can see that 1/3 is greater than 1/4. I want to write 1/3 and 1/4 using the same denominator. In order to find the least common multiple, which is also called LCM, we're going to be listing out the multiples of the two denominators. So what are multiples? Multiples are what you get when you skip count. If we count by 3, we'll get 3, 6, 9, 12, 15, and so on. If we skip count by 4, we'll get 4, 8, 12, 16, and so on. The least common multiple is the first number that shows up in both lists. In this case, our least common multiple is 12. That means we can write 1/3 and 1/4 with the denominator 12. So how do we do that? We need to multiply our numerators and denominators by the same values. So for 1/3, in order to get 12 in my denominator, I'm going to have to multiply that 3 by 4, right? So I'll have 12 in the denominator here. Remember, in order to create equivalent fractions, you have to multiply the numerator and the denominator by the same value. So I'm also going to multiply my numerator by 4. 1 times 4 is 4. This means that 1/3 is equal to 4/12. We're going to do the same to our 1/4 here. I need 12 in the denominator, so I'm going to multiply the 4 by 3, because 4 times 3 is 12. And do the same to the top. I need to multiply my numerator by 3 as well. 1 times 3 is 3. This means that 1/4 is equal to 3/12. Now that we have a common denominator, just like earlier, we can more easily compare these two fractions. We're comparing 4/12 and 3/12. Their denominators are the same, so you can imagine we have two wholes, both of them cut into 12 pieces. but our 4/12 is going to be greater because we're shading in 4 of those pieces instead of 3. One common misconception is believing that a larger denominator means a bigger fraction. So for example, you'll find some people who believe 1/8 is greater than 1/4 because 8 is larger than 4. This is not correct. In reality, when you draw your wholes and divide them into the correct number of pieces, depending on that value in the denominator, you'll clearly see that 1/8, one slice here, is a lot smaller than 1/4, one slice here. In other words, when you divide your whole into more pieces, meaning you have a bigger number in the denominator, each of those pieces is going to be smaller. Another common mistake is incorrectly simplifying your fraction. So earlier I showed you, in order to find equivalent fractions, you'll multiply the numerator and the denominator by the same number. In order to simplify fractions, you're going to divide the numerator and the denominator by the same number. If you only multiply or divide one or the other, so only the numerator or only the denominator, you will not get equivalent fractions. You have to do both. So to summarize, you should remember the following key ideas. A fraction represents a relationship between two numbers, and equivalent fractions represent the same amount simply using different numbers. When we simplify a fraction or find equivalent fractions, we're changing the digits and the numbers there, but the value is the same. Having a strong understanding of fractions is really important for comparing rational numbers, doing decimals and percentages, and other reasoning problems that we're going to encounter on the CSET. Thanks for watching, and I'll see you in the next lesson.